My name is Barry McCarron, and I'm going to present the results of my PhD study into radon concentrations in certified passive house buildings. So, by means of an introduction, I just want to introduce myself. I'm the current chair of the Passive House Association of Ireland. I'm also an expert advisor to the Ministerial Advisory Group on architecture in Northern Ireland, and I'm currently just completing my PhD research, which this presentation is about. The two photographs in the slide are from my place of work. I'm fortunate enough to work in a certified passive house building. The building here in the dark is the Crest Centre, located at Southwest College, and the overhead photograph beside it is of our new Earn campus, which will be a passive house premium building. So I just thought it was worthwhile showing you those photographs. Moving on, I just want to introduce the research. So the overall aim of the research was to understand the relationship between the attributes of passive house building standards and the impact that this has on indoor radon concentrations. So the whole idea was to test the hypothesis that certified passive house buildings, which have an air tightness of 0.6 air changes under 50 pascals of pressure, and of course they have a balanced mechanical heat recovery ventilation unit. So the hypothesis is to see, do these two elements yield lower radon concentrations? The main objectives of the research was to measure actual houses in Ireland and in the UK that are certified passive houses, and also then to assess the difference between indoor radon concentrations in these certified passive house buildings, and then judge them against local, regional, and national references for indoor radon concentrations. So a couple of questions before I introduce to you the results. The research questions focused, there's 5 of them in total, and the first one was, is there a correlation between the air tightness level, the N50, and indoor radon concentrations? Secondly, to investigate the mechanical heat recovery ventilation and see, does it have an influence on radon as well? Third is to see, is there a correlation between the construction type and the indoor radon concentration? The last two are to see, is there a similar correlation in indoor radon concentrations in passive house retrofit or ENERFIT buildings, and see what that is against certified new build as well. And finally, to carry out a comparative case study analysis of certified passive houses that are located in high risk radon areas. So that was the 5 research questions of the study. So for those who may or may not know what radon is, the rough definition of radon is that it's a naturally occurring gas that occurs from the resulting breakdown of uranium in the rocks and soils underneath the ground. The gas is odorless and tasteless, and can only be measured using special apparatus or special equipment. You can see the equipment there in that slide. Out in the open air, radon is not a problem outside. However, in an enclosed space such as a house, once it builds up to a level, it can become quite dangerous. As the radon degrades from uranium, it can leave tiny particles suspended in the air. And as you breathe these in, potentially it can give a radiation dose to the lung. And this is where it becomes a carcinogen and can create a problem. And the risk level goes up dramatically if you're also a smoker, unfortunately. So that's what radon is. So as I said, radon occurs from the geology of the ground and the breakdown of the uranium in soils, as I was saying. So in this slide, you can see a number of maps. And because this is the Spanish Passive House Conference, I've included the most up-to-date map that I could get with radon risk for Spain. So you can see, like it is the same in Northern Ireland, the England and the UK, and also the Republic of Ireland. Spain's map is here, and they all follow the same idea. You can see that in Spain, it's the Gallica region, up in the corner, that is the most high risk region within Spain. So hopefully this is known to some of you. The research as well is very significant, because, as I've outlined, it's a carcinogen. So that's recognized by the World Health Organization and the International Agency for Research of Cancer. Radon is estimated to cause between 3 to 14% of all lung cancers in a given country, including Spain and the Republic of Ireland. Depending on the national average, radon is coupled with occupant smoking prevalence. In addition to this, there's very limited research specifically on certified passive house buildings, and even less with the focus on radon. So that's why I chose to do this subject as well. And of course, the significance of this is also elevated because of the incoming EU directive on the Energy Performance Building Directive, which is due to come into effect on the 1st of January 2021, where passive house is coming to the fore within that. So it's important we know if there's any implications. So this is the first slide of my results or main findings, which I'm going to present to you. And there's a couple of things to point out. The first is there is 97 homes in the sample, and you can see for each of those the corresponding level of radon which was recorded on the graph. You'll also see the error bars. These take into account the maximum possible difference that there could be within the testing. So that's it. And then you'll notice a green line, and at 100 becquerels per cubic meter, that's the units which is used to record radon concentration. So anything above 100 is known as the target level. And then you'll see the red line at 200, and that is known as the action level. So really, in all instances, you want to be below the action level to be safe. And ideally, if possible, you need to be below the target level of 100. So across the 97 results, the average was 36 becquerels per cubic meter in the certified passive house sample. That's 60% lower radon than the Irish national average of 77 becquerels per cubic meter. So that's quite a drop. So that's the first slide of the main findings. The second slide here is a comparison against secondary data which already existed prior to my study. So in the first category here, or part of the graph, you will notice it says EPA 2015 NRS. So that's the Environmental Protection Agency survey of 2015. And NRS is for National Radon Survey. So in that survey, they surveyed 649 homes. 8% of those were above 200 becquerels, which is the action level, and 25% of these homes were above the action level, or the target level, sorry. And we can see there a minimum and maximum, and of course the average at the bottom, which is 77. Within my sample, I said I recorded 97 homes, so it's on the complete other side of this graph, and you can see 97, 0%, none of the homes were above the action level of 200, and 7 were above the target level of 100, which is not too much of a problem. And then you can see that the maximum concentration was 149, and the average is 36, as the previous slide outlined. You'll also notice in the middle, I have a comparison sample. That comparison sample is homes that I also monitored within the study to see were they in line with the national average, and they are. So all in all, you can see that 80% of the sample is below 45 becquerels, which is considered the ALARA principle, or as safe as is reasonably acceptable, and 93% of the sample were below 100, as I said. Moving on then quickly, this is a very straightforward finding. It's just basically outlining the different construction types. So in my sample of 97, 39 of the sample were timber and 58% of the construction type was masonry. So we can see, looking at the downstairs monitor, the upstairs monitor, and of course the average, that the timber construction type had 18% lower radon concentration than the masonry equivalent. So that's an interesting finding in itself. So if you recall back to the research questions I outlined at the start, I have now presented the findings of this in this slide. So you'll see in the first one, the scatter graph, you will see that as we move towards more airtightness, quite logically, the radon level is lower. So we can see I broke down in the other graph from completely airtight to 0.3, and then from 0.3 to 0.6 air changes, and we can see that there's quite a difference, almost a 44% drop when we go down into the next category of air tightness, which is between 0.3 and 0. So it's quite clear that there's a correlation between air tightness and lower levels of radon, which is again logical. So again, you can see the map here of Ireland, and you can see the high risk areas in Ireland. So these homes, which are certified passive houses, were all located in these high risk areas, similar to the Gallica region in Spain, as I outlined earlier. So across the 10, you can see that the blue are all the comparison homes, and the orange is all the certified passive homes. And quite straight away, quite obvious, you can see that house 5, house 6, house 8, 9, and 10 in the comparison homes are all quite elevated. In particular, case study 8 and case study 9, which have really, really high levels. Case study 8 going to almost 600 becquerels per cubic meter, so that's quite dangerous, and 9 as well, just over 400. But we can see quite contrastingly that all of the certified passive houses are very, very low, and all below the red 200 becquerel action level. So, and they're in the highest risk areas, in fact, as well. So the other thing to just point out as well is that 2 of these homes, 8 and 9, are also retrofit as well, which is quite interesting as well, just to point out. Moving on, and again, following the theme of what I just said, the retrofit. So we can see here across the 97, there was 5 interfit or retrofit buildings monitored. So we can see in those as well, when we compare the interfit in the blue and grey graph here to the side, we can see that the interfit is showing lower levels of radon, both downstairs, upstairs, and on average. So we can see that there's an 18% reduction in the interfit sample versus the comparison sample, and a 7% reduction in interfit against the national average as well. So again, both very positive from a passive house point of view. Moving on to some of the last findings in the presentation, we can see here as well, and this was a novel aspect to the study that I wasn't expecting to find, and that is typically in radon monitoring, you will find in a 2-story house that the downstairs level is usually quite higher than the upstairs level. However, in this study, the certified passive house sample had a much closer or much more uniform ratio between upstairs and downstairs than we expected. So we can see across the national average survey, which was conducted in 344 homes, that the downstairs level was 104 and upstairs was 69. In the passive house sample, we can see that the downstairs level was 35 and upstairs 33. So that's much more uniform. So that's only 6% difference versus what is typically found to be 30 to 35% difference between upstairs and downstairs, and there's a reason for that, which I'll come to in a moment. So And that's what I'm doing now. So to discuss that further, we can see there from the last slide, the novel finding was the radon distribution pattern found in the certified passive house sample. And I put this down to the methodology within the passive house standard of having defined supply air zones, extract zones, and of course a transferred air zone in order to allow air to move around the building. And most of you will be quite familiar with the underpass underneath the door or an overflow above the door to facilitate this. So I put the cross flow principle at the heart of this difference in radon distribution, which contrasts greatly against traditional radon monitoring in standard homes. So that's an interesting finding. Previous research had outlined that that this gap is typically 35%, and as I said in the last slide, mine was down at 6% difference, so that's quite different. So there's an opportunity for further research in this space, looking into how this could be done, and again, it could be done in Spain as well. I've had some interest from some universities in Ireland to progress this further. One of the last slides here is the recommendation. So what I found was, generally speaking, in construction, we have a number of different ventilation systems coming onto the market, and of course this sort of comes into the passive house space to some degree. So I constructed this risk matrix as well, which you'll see in the slide. So I have the various ventilation systems all listed, which are common to Ireland. So positive input ventilation, which creates a positive pressure. The air is filtrated. There's no heat recovery. The radon risk is low and the moisture risk is high. Looking at natural ventilation, which is very common, again, the pressure is variable because the wind dictates how much ventilation there is. There's no filtration, no heat recovery. Radon risk is medium, and the moisture risk is low. Then looking at MVHR, which is for certified passive house, we can see the balanced pressure. Yes, there's infiltration, filtration, there's heat recovery, the radon risk is low, and the moisture risk is low. Then we have demand controlled ventilation again, which follow similar attributes to the MVHR. And then, of course, extract ventilation, which creates a negative pressure, no filtration, no heat recovery, high risk radon, and low moisture risk. The reason the extract potentially has a high radon risk is because it creates a negative pressure or a suction on the building fabric, which could encourage radon into the home. So the other recommendations I have are around radon particles are suspended in air, as I said at the start. However, they stick to dust particles. So if we can introduce an F9 filter rather than an F7 filter in regions of high risk radon, then that would be a good recommendation. So in the Gallic region of Spain, perhaps if you're building a passive house there, it could be a good idea to specify an F9 filter rather than an F7. Again, this won't result in a pressure drop or a significant pressure difference as well, and it's not that much of an expense as well. Higher levels of air tightness could also be pursued in high-risk areas as well. So again, a high-risk area, we could go for even a higher level of air tightness, which would help mitigate the risk of radon in the home. And also at the commissioning of the MVHR system, which is to be balanced within 10%, it could be an idea to slightly balance it on the positive pressure side so as not to induce or encourage ingress of radon into the home. There we are. So in conclusion, certified passive house successfully mitigates against high indoor radon concentrations. The MVHR systems are responsible for closer radon distribution levels between upstairs and downstairs. Certified passive house guidance on quality and certification, I believe, has had a direct influence on that performance that we found in this study. EnerFit is also an effective methodology for successful retrofit without increasing radon levels. And finally, timber as opposed to masonry. It looks like it's a better material with regards to background radon levels as well. So that's the conclusion. And finally, my contact details are here at the end of the presentation. So if you need to contact me, I'm on the various social media, and you also have my email address there. So I'd be delighted to hear some feedback privately if you want to pursue that. Okay, so thank you very much for your time, and I look forward to hearing some questions. All right.